Take a good look at this. This is a full-size luxury SUV. 5 meters long, 2.5 tons. The kind of vehicle that's supposed to be about as athletic as a refrigerator. And it just jumped. All 4 wheels off the ground. At the same time, no ramp, no crane, no camera tricks. That jump was powered entirely by the car's own suspension. Actuators at each corner compressing and releasing with so much force and so much precision that they can throw 2.5 tons of metal into the air like it's nothing. Now here's the part that should really get your attention. The jump is the least useful thing this suspension can do. It's a party trick, a flex, what the same hardware does on an actual road. That's what we're here to talk about, because this car can drive with a missing wheel. It can hop over obstacles instead of swerving around them. And it can survive a tire blowout at highway speed without the driver even flinching. This is the AITO M9. And behind it stands a company that 5 years ago had never built a single car. Huawei. Today, we're breaking down what might be the most advanced suspension system ever fitted to a production vehicle. How it works, what it can actually do, how it stacks up against the best from Mercedes and Porsche, and what it tells us about where this entire industry is heading. Welcome back to Camber and Curve. Before we tear into the suspension, you need to understand what this car is, because the story behind it explains everything about how it drives. AITO is not a traditional automaker. It's the product of a partnership between Seres, a Chinese manufacturer most people outside China had never heard of, and Huawei. Yes, that Huawei. The telecom and smartphone giant. When the United States cut Huawei off from the global smartphone supply chain, the company needed somewhere to redeploy an army of engineers and billions in R&D. They chose cars. But here's the key detail. Huawei doesn't build the body or stamp the metal. Huawei builds the brains. The electric drive units, the software, the sensors, the driver assistance stack, and the chassis control system we're covering today. They call it the Tuling Chassis, sometimes translated as the Turing Chassis, named after Alan Turing, the father of computing. And that name is not marketing fluff. It's a statement of philosophy. Because this suspension is not fundamentally a mechanical product. It's a computing product that happens to have springs attached. Now, to understand why that matters, let's look at the 3 levels of suspension technology. Level 1, the car in your driveway. Almost every vehicle on the road today has passive suspension, springs and dampers with fixed characteristics. They react to the road always the same way, whether you're on glass-smooth asphalt or a gravel trail. Level 2, the traditional premium brands. Mercedes, BMW, Audi. Their flagship models offer adaptive suspension, magnetic ride, adaptive dampers, air springs. These can change their stiffness in real time, softening for comfort, firming up for corners. Better, but still fundamentally reactive. The wheel hits the bump first, and the system responds after. And level 3, this is where the AITO M9 comes in. The M9 uses fully active suspension, and that is a different species entirely. In the M9, each wheel gets its own actuator that can actively push down or pull up, independently, with real force, in milliseconds. The system doesn't just absorb what the road throws at it. It generates its own forces, and the M9 combines that with cameras and sensors scanning the road surface ahead. The result is something remarkable. This car sees the pothole before the tires ever touch it, and preloads each corner of the vehicle for exactly what's coming. The AITO M9 doesn't react to the road. It anticipates it. That's the theory. Now let's see the receipts. So instead of a press release, they released footage. And this footage is why we're making this video. Test number 1, the jump. We opened with it, but let's appreciate what it actually demonstrates. To launch a vehicle this heavy off the ground, the actuators need enormous power density and enormous speed, full compression to full extension in a fraction of a second. at all four corners, perfectly synchronized. No adaptive damper on Earth can do this. Dampers can only resist motion. These actuators create it. Test number 2. And honestly, this one is my favorite. They removed an entire front wheel, took it clean off, and the M9 drove away, not dragged itself, not limped. It drove, steered, maneuvered, and then reverse parked on 3 wheels. The suspension detected the missing corner and redistributed the load across the remaining 3 wheels in real time, constantly rebalancing the body like a person adjusting their stance after spraining an ankle. Think about what that means in the real world. Catastrophic wheel or hub failure at speed no longer automatically means losing control of the vehicle. Test number 3. The obstacle. A water bottle sitting in the middle of the lane. Every car you've ever driven gives you 2 options: swerve around it or hit it. The M9 chose option 3. The forward sensors identified the obstacle, calculated its height, and the suspension raised the entire chassis in milliseconds. The car simply stepped over it, like a person stepping over a puddle. No steering input, no lane departure, just over. Now replace that water bottle with a brick, a muffler, a piece of truck tire on the freeway at night. Swerving at highway speed is one of the leading causes of single-vehicle rollovers. A car that can clear the obstacle without changing lanes isn't just clever, it's fundamentally safer. Test number 4. The torture track. Continuous speed bumps, broken pavement, staggered potholes. The kind of surface that makes passengers grab the door handles. The footage shows the M9 crossing it with graphic overlays on each wheel, and you can see each corner working independently. One wheel dropping into a hole, while the opposite corner pushes up. Wheels hammering up and down like pistons, while the cabin glides forward almost perfectly level. The suspension is essentially decoupling the passengers from the road. The wheels live in chaos. The cabin lives in peace. Test number 5. The blowout. This is the serious one. The M9 running at roughly 200 kilometers an hour, about 125 miles per hour, and a tire is deliberately blown out. At that speed, with a conventional car, this is an emergency with a real chance of ending in a barrier. The M9's response: the system detected the failure instantly. The active suspension compensated for the sudden collapse of that corner. Torque and braking were rebalanced, and the car tracked dead straight. The driver braked, changed lanes, and pulled over like nothing happened. That's not a comfort feature. That is genuinely life-saving technology. And test 6, the trench run, shallow potholes, deep ruts, sharp-edged trenches, even a section littered with nails. The system classified each hazard and chose a strategy per wheel, sometimes lifting the body, sometimes softening one corner, sometimes stiffening the opposite side, to minimize impact energy every single time. This is what reading the road actually looks like when it's real. All right, impressive footage. But camber and curve viewers know the next question. Hasn't the West already done this? Partially, and the details matter. Mercedes-Benz offers e-active body control on the S-Class and GLS, a 48-volt hydraulic system that can control each wheel individually, lean into corners, even bounce the car to free it from sand. Genuinely one of the finest suspension systems ever engineered. Porsche's active ride on the Panamera and Taycan might be even more impressive. It can keep the body completely flat through hard cornering and braking, and it politely lifts the car when you open the door. Nobody is calling these systems inferior. They're spectacular. But here's the uncomfortable part for the legacy industry. First, price and positioning. Those systems are crown jewels reserved for 6-figure flagships, developed across decades of iteration. The M9 sells in China for roughly the equivalent of $70,000 to $80,000. Flagship-level tech at a price that undercuts the Germans by a massive margin. Second, speed. The Chinese industry went from being mocked for copying suspension designs to shipping fully active, camera-guided systems in about a decade. Huawei isn't alone either. BYD's Desus X system does its own party tricks. including making cars dance and jump. This isn't one company showing off. It's an entire industrial ecosystem hitting its stride simultaneously. And third, maybe the most important point, the philosophy is different. Mercedes and Porsche approached active suspension as a mechanical refinement problem. Huawei approached it as a computing problem. Sensor fusion, prediction algorithms, millisecond actuation. The same engineering DNA as autonomous driving. And when suspension becomes software, it improves over the air. Your car's ride quality can literally get better with an update, the way your phone does. That's a fundamentally different product lifecycle than anything the traditional industry has offered. Is there a catch? Of course there is. And we'll get to it. But the benchmark has moved. That much is not up for debate. So let's land this thing. Is the AITO M9 suspension the future of the automobile? My honest answer, yes, with an asterisk the size of a billboard. Fully active suspension is heavy, expensive, and complex. Every actuator, sensor, and control unit is a component that can fail. And nobody on earth can tell you today what one of these systems costs to maintain in year 8, known out of warranty, at an independent shop. Traditional springs and dampers survive decades of abuse. Precision actuators fed by camera data. We simply don't know yet. If you're the kind of buyer who keeps a car for 15 years, that question should genuinely bother you. But zoom out, because the bigger picture is what this channel exists for. For 100 years, suspension advanced by inches. Better geometry, better dampers, incremental refinement. What you watch today is not an inch, it's a leap. The moment the chassis stopped being pure mechanics and became robotics. And the fact that this leap arrived from a phone company in a family SUV at a mid-tier luxury price tells you exactly how much the balance of power in this industry has shifted. The question is no longer whether Chinese automakers can compete on chassis engineering. They can. The question is how fast Stuttgart, Munich, Detroit, and Tokyo can respond, and whether their business models even allow them to respond at this price. We're going to be covering every battle of this suspension arms race right here. So if this video taught you something, do me a favor. Subscribe to Camber and Curve, ring the bell, and drop your take in the comments. Would you trust a car that jumps? Would you pay for suspension that thinks, I read everything, and the best comments shape future videos? Thanks for watching. Stay low, stay smooth, and I'll see you in the next one.